Welcome to This Explainer. Okay, forget absolutely everything Hollywood taught you about massive jaws and dorsal fins ominously cutting through the water. Today, we're diving into the fast-paced, terrifying world of microscopic and chemical marine assassins. These are killers so small you literally won't even know they're in the water with you, until it's way too late. Let's get right into it. So, what's the deadliest creature in the ocean? Most people instantly picture a massive great white shark breaching the surface. And sure, out of 949 confirmed unprovoked shark attacks in history, great whites are responsible for 351 of them, with 59 fatalities. But if we measure danger by toxicity instead of size, the truth is so much smaller, far stealthier, and astronomically more lethal. Just picture a colossal 1,000-kilo saltwater crocodile, the undisputed largest living reptile on Earth. It crushes you with sheer mechanical force. Now compare that to the adorable, literally pocket-sized blue-ringed octopus. This little guy uses a venom so unimaginably potent that a single near-painless bite rapidly causes fatal paralysis. It flashes those beautiful iridescent blue rings as a final warning, and if you ignore them, there is absolutely no antidote. Which brings us to Section 1, the ultimate chemical assassin. Meet tetrodotoxin, or TTX for short. This is the very neurotoxin wielded by that little octopus, and it is roughly 1,000 times more toxic to humans than cyanide. 1,000 times! And because it's a non-protein toxin, its resilience is honestly terrifying. You can boil it, fry it, stew it for hours. It doesn't matter. Intense heat can actually increase its toxic effect. Just 1.5 to 2 milligrams, literally the size of a single grain of salt, is a completely lethal dose for a 50-kilo human. And again, no known antidote. Just look at the sheer complexity of the TTX molecule here, C11H17O8N3. This dense web of carbon, hydrogen, oxygen, and nitrogen is an absolute biological masterpiece of destruction. But here's the crazy part. Where does it actually come from? Well, scientists believe this chemical assassin originates from marine bacteria like Vibrio and Pseudomonas. The marine animals don't produce the toxin themselves. They bioaccumulate it right up the food chain, storing it intensely in their livers, gonads, and skin.
Section 2. How tetrodotoxin shuts us down.
So how exactly does this tiny molecule take down a full-grown human? Well, normally, voltage-gated sodium channels in our cell membranes allow sodium ions to pass through, transmitting vital electrical signals for our nerves and muscles. But TTX acts literally like a microscopic cork. It physically wedges itself right into that channel, completely blocking the sodium ions. No ions mean no electrical signals. It is that simple and that devastating. Your brain just stops being able to talk to your body. Because of this microscopic roadblock, the body's shutdown is terrifyingly fast. Within just 5 to 15 minutes of ingestion, victims feel a distinct tingling spreading rapidly across the lips and mouth. That's quickly followed by severe stomach aches and violent vomiting. As the blockade spreads, it causes severe muscular paralysis. Ultimately, your diaphragm stops getting signals from your brain, leading to respiratory collapse and complete cardiac failure. With a high enough dose, this entire process can kill in just 20 minutes. So where is this hiding in our food chain? Pufferfish, famous in Japan as the incredibly expensive delicacy fugu, account for a massive 75% of poisoning cases. But get this, gastropods, like sea snails and trumpet shells, make up nearly 19% of cases. This is a rapidly rising threat because people blindly forage for them, or they get misidentified and mixed into global seafood markets, completely surprising unsuspecting buyers. Moving on to Section 3, Invisible and Tiny Terrors. Now we're shifting from food to the immediate hazards actively hunting in the water with you. 12 by 25 millimeters, that is the exact adult size of the irukandji jellyfish bell. It is practically invisible, significantly smaller than your thumb, but trailing behind that tiny, transparent bell are 4 tentacles that stretch up to an entire meter long, and every single millimeter is fully armed with microscopic stinging cells. Unlike most jellyfish, the irukandji uniquely fires venom directly from the tips of its tentacles. The initial sting is incredibly light. People usually just brush it off as sea lice, but then it triggers irukandji syndrome. This is a delayed but excruciating cascade of full-body agony, extreme hypertension, and pulmonary edema, meaning your lungs literally start filling with fluid. The whole nightmare lasts for about 24 hours. And a wild fact here, Dr. Jack Barnes actually discovered this in 1961 by intentionally letting the jellyfish sting himself, his 9-year-old son, and a lifeguard just to observe the symptoms. Unbelievable.
Then, of course, we have its monstrous cousin, the box jellyfish. This creature absolutely does not delay its symptoms. It drags 3-meter-long tentacles heavily loaded with toxins that violently strike the heart, nervous system, and skin cells all at the exact same time. The pain is so instant and agonizing that victims regularly go into shock and drown, or suffer catastrophic heart failure within 5 minutes. 5 minutes! Often way before they can even make it back to shore.
Section 4. Physical predators and spines. Keep in mind, not all of these terrors are drifting in the open water. Some are heavily armored and waiting patiently right beneath your feet. Take the stonefish. It uses perfect, texturally flawless camouflage to look exactly like a harmless rock. Step on it, and defensive dorsal spines inject venom that causes immediate tissue necrosis, literally killing your surrounding cells, along with mind-numbing pain. On the flip side, the seemingly harmless cone snail actively hunts by shooting a hollow, venom-filled harpoon. It paralyzes instantly, there's no antivenom, and it has killed dozens. Seriously, never pick up pretty shells. Finally, Section 5. Ocean First Aid Essentials.
Okay, we've covered a lot of deep-sea nightmare fuel, but the whole point of this explainer is to give you the exact actionable steps to survive. For physical punctures from a stonefish, stingray, or sea urchin, your absolute first line of defense is heat. You want to immerse the wound in very hot, but not scalding, water for 30 to 90 minutes. Why? Because the venom is often protein-based. Intense heat actually denatures or chemically destroys those toxic proteins before they can do maximum damage. After a long soak, carefully remove any remaining spines with tweezers and wash thoroughly with soap.
However, for highly toxic, paralyzing strikes from things like a cone snail or a sea snake, heat simply won't save you. You have to immediately apply a firm pressure bandage to physically halt the venom spread through your lymphatic system. But you have to be incredibly careful here. You must ensure blood circulation continues. Do not create a restrictive tourniquet that cuts off blood flow entirely, or you risk losing the limb. Once that bandage is on, rush to get emergency medical care. As we wrap up, there is a pretty sobering reality check we have to face. We are already seeing deadly TTX-bearing pufferfish invading the Mediterranean Sea through the Suez Canal. As global ocean temperatures continue to predictably rise, these tropical terrors, including the agonizing Irukandji jellyfish, are drastically expanding their historical territories. Which leaves us with one chilling, unavoidable question. As the oceans warm, what invisible, microscopic terrors might be waiting in the water at your local beach next summer? Thanks so much for joining this explainer. Stay safe and respect the ocean.